Good morning students. In the previous video session you have gone through centripetal force. Also you have learned how the centripetal force is arised from other forces like gravitational force, frictional force and tension and all. And today you can see that a vehicle on a leveled circular road. Assume that one vehicle is traveling in this curved path. So if this vehicle is traveling in this curved path means there must be some centripetal force acting on it. We know that when an object is moving in a circular path, object means any vehicle which is moving in a circular path, it needs some centripetal force. And here we can see that this is a car. This car is moving on this curved path, and here this direction you can see the centripetal force is acting, and this centripetal force is given by what? This centripetal force is provided by the frictional force between this tire and road. I said that in the previous video session also, centripetal force is arised from frictional force, gravitational force, tension and all. And here when this vehicle turned on this curved path, here centripetal force is acting on it, and this centripetal force is provided by the frictional force between this tire and this road surface. So we can consider one vehicle moving with a mass m, and it is moving with a speed v on the circular track, r we can consider. So there are some forces acting on this. What are the forces acting on this car now? We know that the downward force is acting. Here downward force is acting. mg is the downward force, and upward force, normal force is acting. Also the frictional force is acting. This is like this frictional force is acting. So assume that if the road is horizontal, you can see here there is a horizontal road showing. Suppose this road is horizontal road, then you can see that the two forces acting, downward gravitational force and what? This normal force which is acting exactly in the equal and opposite direction. That is what happening. So I said here, when this car turned on this curved track, it possesses some centripetal force, and this centripetal force is provided by the frictional force between this tire and the road. And here what are the forces acting on it? Downward gravitational force, upward normal force and frictional force is acting. Suppose if you are assuming this road is a horizontal road, so that we know that there are two forces which is acting, downward gravitational force and the upward normal force which is acting in the exactly equal and opposite direction. Now what will happen means, here when it is turning, so that the centripetal force is provided by the static friction between this tire and the surface of the road. So that we can write mv square by r is provided by what? Static friction. So by using this, we know that we have already seen that frictional force, static friction can increases from what? 0 to any maximum value. So from 0 to any maximum value, this frictional force can increase. So you can write a relation. Frictional force is so this is a relation. Frictional force is less than or equal to mu s mg. So we can apply two conditions when the car is bending on the circular track. Actually here you can see these two conditions. What are the conditions you see? So first condition is, if mv square by r is less than or equal to mu s mg. So this is a condition. So what happened means, we know that the static friction is increases from the value 0 to what? Maximum value, any value it is increasing. So based on this condition, we are taking two conditions. Let us see what is the condition. So here you can see that Fs is what? mv square by r. So the static friction is providing the centripetal force, and this centripetal force mv square by r is less than or equal to mu s mg means what is this? So this centripetal force is less than the static friction. That is what? That is what here it is meaning. So if the centripetal force is less than this static friction, so that what will happen means this static friction can be able to provide the necessary centripetal force to bend the car on this level road. So what will happen means the coefficient of static friction between this tire and the surface of the road with the maximum speed of this car, they can turn the car safely. So if the static friction providing the necessary centripetal force for the vehicle to turn on a road, suppose assume that the car is moving with a heavy speed, suddenly he saw that in front of him there is a curved road. Suddenly he will turn the vehicle. That time the static friction is providing the enough centripetal force. That's what the car is moving safe turn, we can tell. Otherwise the car may met with an accident. It may turn, roll down or during turning this curved path. So this is the condition mv square by r. The centripetal force is less than this coefficient of static friction, so that this coefficient of static friction can be, the static friction would be able to provide the necessary centripetal force on this car to bend safely. So this same equation you can write in another way also. Suppose if you are taking mv square by r is equal to mu s mg, if you are taking, we can write this equation. So mu, you can see here cancel, we can take so that v square by r is equal to mu sg. From this mu sg equal to v square by r you can take, so that mu s is equal to v square by rg you can take. So now you can write this relation only. You can write mu s is greater than or equal to v square by rg. So this should be the coefficient of static friction should be greater. So like this also you can write the relation, like this also you can write the relation, both are same. Then from this equation also you can write you see mu s is greater than or equal to v square by rg. From this you can write you can write mu s rg is greater than or equal to v square. So root of mu s rg is greater than or equal to v also you can write. So you can satisfy these three relation. So for these three relation, what is the conditions? The static friction can be able to provide the necessary centripetal force for this safe turn. So this is the condition one. This is one important question. And the second condition is, if mv square by r is greater than mu s mg. Now what will happen? You see, now the condition is centripetal force is more than the static friction. So centripetal force is greater than the static friction means the static friction will not be able to provide the enough centripetal force to turn. So what will happen? During this time the vehicle will start to skid when you turn on a circular road. This equation you can write in another way also, or you can write mu s is less than v square by rg. So how you can take means like this, you can take mv square by r is equal to mu s mg. So cancel. So v square by rg is equal to mu s. So from this you can write the relation. Mu s is less. So that you see the static friction is less than the centripetal force. So that the static friction will not be able to providing the enough centripetal force to turn. So what will happen? The vehicle will start to skid. This is one of the important question. Condition for skidding and for the safe turn. So safe turn condition is this one. This is an important 2-mark question, and this is your first assignment of this week. Conditions for skidding and conditions for what? Safe turn. So take this as your assignment, and all of you study this question. Next topic is banging on track. Banging off track. What is this banging off track? Actually, this banging off track means in our daily life we are seeing this banging off track on this road and all, but we don't know what is that. Actually, this banging off track means nothing. Assume that on a leveled circular road, there the skidding is happening. Mainly, what is the reason? Because of this coefficient of static friction only. So I said we have learned the conditions for skidding and for the safe turn. So skidding, what will happen? The coefficient of static friction cannot be able to providing the necessary centripetal force, so that the car is skidding or any vehicle is skidding. So actually, to avoid the skidding problem, what the engineers do means, we can see that the outer edge of the road is slightly rising like this. So suppose this is a road, then this outer edge slightly raised like this if there is a curve. So if you are comparing this outer edge and this inner edge, this outer edge is little raised than the inner edge. And when you are traveling in bike or motorbike or car, you can see that if there is a big curve and all, there you can see that the outer edge of the road is raised little more than the inner edge of the road, and this is what we are saying banging off track, or you can tell that banging off road or banging off track. And this, so while making like this, the outer edge is little rising, outer edge is rising more than the inner edge. There is an angle of inclination forming that, and that angle only it is saying that banging angle. You can see this diagram. So you see, so what is happening means, on this curved surface, this outer surface, this is a outer edge and this is a inner edge. So this outer edge you can see that a little raised more than this inner edge, so that here there is an angle of inclination. So that what is happening, an angle is forming here, that angle only it is saying banging angle. Now in this diagram you can see that you see some of the forces acting on this also. What are the forces? Downward mg is acting and upward normal force is acting, and here this angle of inclination is forming with this normal force n, so that this n is splitting into two components, n cos theta and n sin theta. And what is the use of this n cos theta and sin theta means, this n cos theta is used to balancing this downward gravitational force. Also you can see this n sin theta. What is the use of this? This n sin theta is providing the necessary centripetal acceleration. So what is meant by banging off track? So to avoid the skidding problem, usually the outer edge of the road is slightly raised compared to inner edge, and this is called banging off track or banging off road, and it is introducing an angle, and that angle is banging off angle we are saying. Now this the forces acting on this, you can write what are the forces acting on it when a car taking a turn on this curved road. What are the forces acting? Downward gravitational force and upward normal force. And here there is an angle of inclination, so that upward force, normal force is splitting into two components. So let us see what are the components. So this normal force is resolved into two components, n cos theta and n sin theta. What is the use of this n cos theta and n sin theta? So this n cos theta is used to balance this downward gravitational force mg, and this n sin theta is used to providing the enough centripetal acceleration. So it is a long answer question number 10. So n cos theta, what is the use to balance mg? This you can take 1. And n sin theta, what is the use? It is providing the centripetal force, mv square by r. So you can take 1 and 2. Now what you have to do means divide 2 by 1. So when you are dividing this 2 by 1, n sin theta by n cos theta equal to mv square by r divided by mg. So here we can write n sin theta by n cos theta equal to mv square. This r you take down, r mg. So m cancel, n cancel. Sin theta by cos theta we can write tan theta. So tan theta is equal to what will come? V square by rg. So tan theta is equal to V square by rg. From this we can write we can find out the V. So what will come? V square by rg is equal to tan theta. V square is equal to rg tan theta, cross multiplication. So V is equal to root of rg tan theta. So this is the equation. So based on this equation only, that rod banging of track and all made. And if you are calculating the theta value, banging angle theta, and the radius of the curvature of the rod, so that we can determine the safe speed of the car at that turning. We can see that when we are moving in some turning and all, there it will be written 20 meter per second or 25 meter per second, like that, or 20 kilometer per second, like that it will be written. So that you can see the signboard, speed board. So if we are using the safe speed, easily we can turn the car without skidding, without falling. Actually assume that your speed of the car is exceeded. Maybe on turning it is written 20 kilometer per second. So 20 kilometer speed it is written, but you are going some 22 or 25 kilometer. So if you are going 25 kilometer speed, that time what will happen means, maybe that frictional force is providing the enough centripetal force, so that you can turn in that turning with safely. But sometimes what will happen means, sometimes we used to turn that car with very less speed. Suppose in that road you have to travel with 25 kilometer, but you are moving with some 15 kilometer speed or something. That time what will happen means, maybe we will skid in the inner edge. We will skid and we may fall inside this rod. So that time also what will happen means, this static friction can be able to provide necessary centripetal force, so that you can turn in that curve so easily. And I said that if you are going, maybe that car, it is the speed, the maximum speed you have to use is 20 kilometer, but you are using 25 kilometer speed. The time your car or your vehicle will skid outward direction, outer edge you can tell. So this is what is happening. And if you are moving with 30-40 kilometer speed on that car, surely you will fall and you will meet with an accident. And this is calculating based on this banging of track, and you can see this calculation. So again, what is meant by banging of track? So to avoid the skidding problem, the outer edge of the road is slightly raised compared to the inner edge. That is what we are saying, banking of track. And during this banking of track, you see, when a vehicle moving on this circular curved road, what will happen? The force is acting is downward gravitational force, upward normal force, and this normal force resolved into two components, n cos theta and n sin theta, and n cos theta is used to balance this mg, and n sin theta is used to for what purpose? To provide the centripetal force, enough centripetal force. Now you see here, you can see based on this derivation, n cos theta is used to balance and n sin theta providing centripetal force. We are dividing these two equations that much only. So n cancel, sin theta by cos theta is tan theta. Here cancel, v square by rg. So v square by rg is equal to tan theta, v square is equal to rg tan theta. You can take this root. So if you are calculating the radius of coverage r of the road or the track and the angle of inclination, the banking angle, easily you can find out the safe speed on the car, turning at data, turns on data, turning. Based on data, you have to move your vehicle, and this is long answer question number 10. Here I am showing, you can mark it and study. So this thing, then this paragraph also. So this is a conclusion, you have to learn this paragraph. This is nothing, we are calculating this theta and this r, so that we can find out the safe speed of the car at this turning. So what will happen if the car is exceeding this safe speed? What will happen? This frictional force between the tire and the surface of the road will providing the kind of centripetal force, so that what you can do means to prevent from it will prevent your car from outward skidding. And if you are moving with the less speed than the safe speed, what will happen? Your car will skid inward direction. So if you are moving very fast, it is uncontrollable means surely will our vehicle will get a skid. And my dear students, go through this. All of you learn this question. It is an important question, banking of track. Also these conditions for safe turn and conditions for skidding. These two questions are important. All of you study this. Thank you all. Bye bye.